in the consequence.
Okay.
You go, your number's at the top. Yes, you can. Here you go. Your number's at the top. So I think we're missing some. Samantha's not here, and
Carissa,
Carissa.
is Houston with us?
Okay. All right. All right. Come on, Charlie. Okay. Okay. Huh? Yes. You want to run down to Mr. Hilder's room and see if you can get a water bottle from him? Thank you. Okay. So, make sure your name, don't work ahead. Make sure your name is at the top, the date, okay? The second page right here is your warm-up. Today, we will be going over Kepler 47C, okay? So, what you're going to do is you're going to use your knowledge from previous lessons that we went over, analyze the... He doesn't have any? Okay, that's okay.
What's the date?
Today's date is the 20th. Okay. So you're going to use your knowledge of lunar... Okay, I'm going to set these right here, okay? Okay. So... Are you in the restroom?
I was filling my water bottle up.
Okay. I'll get to you here in just a second, Rochelle. Alright. What you're going to do is you're going to use your knowledge of lunar phases and predict the lunar phases on, hey, don't work ahead, please. Just wait a second.
I'm just
Okay. So, sort and analyze evidence. Use your knowledge of lunar phases on our own moon to predict how Kepler 47C's moon will or will not have a lunar eclipse. Okay? So, this is your warm-up. Your warm-up asks you to look at several different images of our solar system. You have 3 questions on there. Okay? You're going to answer the questions by looking at the images. Use what you know about previous lunar eclipses and lessons that we've done and different concepts that we've learned to be able to answer your question, to answer it correctly. So, I know it's kind of hard to see because it is black, like the printer messed up. So, the first one is the Earth. The next one is our solar system. This one right here is the Milky Way galaxy on the very end, and then our observable universe. Okay? So, it's going to ask you, do you think that other galaxies look similar or different? How is the star system different from our solar system? And I know you can't really tell, but make an observation. And then, what do you think would be different if you were on the planet in a different solar system? Okay? So it's all up to what you think. I'm going to give you 5 minutes. Please use the time carefully, okay? That's going to be a zoom. So, yes, it's going to be a more zoomed in Yeah. So it's gonna be two, it looks like it's two suns, and then this is a planet right here. So two suns and a planet. So Slade had a really good observation on this one. This picture right here is two suns, like two stars, and this is a planet, okay? So you know how we have our sun in the middle of our solar system? That one has two suns that it's wanting you to look at, with a planet kind of zoomed in. It's not to scale. Yes? Yes. I'll try to do that. I don't think that it's going to allow me to do that, so. Let's see. I think it cuts off right here. So, the Milky Way galaxy is a zoomed out picture of the whole entire galaxy, okay? The observable universe looks like different particles floating in the air. You know, whenever the sun comes in and you see dust kind of floating everywhere, this is what that picture kind of looks like, okay? Our solar system is a zoomed out image of the sun in the middle, and then you've got Mars, Venus, Neptune, Uranus, all that, and their orbits, okay? So it's kind of like a zoomed out picture, and then it's got a picture of the Earth, and we've got our moon around the one that says Earth, okay? So this one right here is a planet, and then these right here are two suns. So, or two stars, kind of like the sun. I'll come to you here in just a second. Hold on 1 second. So he's asking me right here, how do you think other galaxies might be similar or different from our Milky Way galaxy? This one right here. It's called the Milky Way. So how are they the same, or how do you think that they would be different? Yeah. And this question is asking me, how is this solar system different from our solar system? It's got two suns, and it's got two stars. What did you say? Potter. A little bit of a little check on. Yes. And what's this? Water. W-A-T. Perfect. Water would be the whole. Okay. Yes. Yes. Okay. Yes. Okay, so this is asking you, what do you think would be different if you were on a planet in this solar system, like if you were on this planet right here with two stars? What do you think we would feel? What would be different about it? So this is asking you, what do you think would be different if we were on this planet right here that has two stars? Or two suns, right? Okay. Charlie, you good? Okay. Okay, I'm gonna give you about 30 more seconds and then we need to move on. Okay, so planetary sciences use what they know about Earth and what goes on around Earth to be able to evaluate claims about other planets. The same laws of physics that govern our solar system also hold true for other planetary systems. So, over the next couple of lessons, we're going to be using what we know about Earth, Moon, and Sun to determine what we think to be true about other planets and other stars. So, we had this email. Y'all remember Eric Wu? He was trying to figure, what was he trying to figure out?
I take a picture of the moon.
Yes, but specifically what? Uh-huh. 3 craters, and then what's that imaginary line in the middle? What's it called? That separates light and dark on the moon. Starts with T. Remember I told y'all that it's the same word as a movie. Terminator. Yes. Okay. So this man right here we figured out about when the best time to take the picture was. So the editor of the magazine that he works for wants to draw some realistic pictures of Kepler 47c, which is a newly discovered planet that orbits around 2 stars. The photos of the lunar eclipse is what she's wanting to draw it, but she wants to know if she can include in her drawing or not a lunar eclipse. Okay? So our question is lunar eclipses even possible if the planet orbits around 2 stars? Is it likely that Kepler 47c's moon will ever completely be dark? Can you help her figure out? And they're sending some data for us to figure out. Okay. So do what?
It may be possible.
Okay, so we're gonna figure it out. Yep. Okay, so during a year there will be a lunar eclipse. During a year, will there be a lunar eclipse of the moon on Kepler 47c? So, these are our science claims. They are possible answers to our question about whether a lunar eclipse of Kepler 47c's moon is likely to happen during 1 year span. Okay, so claim 1 says yes, there will be a lunar eclipse. Claim 2, no, there will not be a lunar eclipse. First, we're going to figure out if it's possible to have a lunar eclipse on Kepler 47c's moon, or if it's probable. So, what is the difference between possible and probable?
Possible means it
Wait, raise your hand. Thank you.
Possible means it will happen, and probable means like it may happen.
Okay.
It's not impossible.
Okay.
Yeah.
Possible means that it can happen. Doesn't mean it's going to, but it can. And probable means that it is likely to happen. Okay? So, let's talk about exactly what is Kepler 47c. Because how many of you have ever heard of Kepler 47c? Okay. Nothing specific? Okay. So, it is a planet located in, what's that word? Anybody tell me? Cygnus, okay. It's a constellation that we see from Earth's northern hemisphere during summertime. Kepler 47 is about 5 times the size of Earth. Each orbit has 1 star, so the Earth's orbit has 1 star in the middle of the solar system. Kepler 47c orbits 2 stars. These stars are about the same size as our sun. The moon on Kepler 47c is a sphere, just like our moon that we see every day and every night. So, you will examine evidence cards. They are on your desk. Your group will have one. You're going to build arguments whether or not yes, there probably will be a lunar eclipse, or no, there probably will not be a lunar eclipse. You're going to annotate them, look at them, and gather evidence from them. So first, let's start with card A. So, I just need you to put the rest of the stuff aside, the rest of your cards in the deck aside, and I just need you to look at evidence card A. Okay? Now I want you to share, kind of think and share with your group. Look over the card, kind of figure out what is the card telling you. What piece of evidence is it telling you? Okay, I'm gonna give you a couple of minutes to do that. What do you think? What do you think with this? What do you think it is? What do you think it's talking about? Talk amongst yourselves, okay? What do you think it is, Charlie? What do you think? Look at it, get in and look at it. Talk amongst yourselves about it. Ruby, what do you think it is? What do you think it is?
What do you mean, think it's possible?
What do you think it is? Like, what do you think this whole thing right there is? What do you think it is? You just look at evidence card A, did y'all look at it? Okay, what did y'all figure out? What do you think it's talking about? On our planet? Alright, that orbits our planet? Is it a model of our solar system? What model is this showing us? Yes, correct. Okay. Good deal. So, what I would like for you to do is annotate the card and discuss these questions with your partner only by looking at evidence card A. Okay, so we figured out what it was. All right, let me pick. We'll go with Caleb. What is the card talking about? What is it showing us?
It's showing us that it's not like our solar system, and that Kepler 47c's moon is orbiting around 2 stars.
Okay, so what is it? What is it, Ruby? What is this a representation of? What's the word that we use? Is this a picture? Is it a drawing? It's a model. Yes, it's a model. Okay, so you have two questions. Is a lunar eclipse of Kepler 47c's moon possible based on this evidence? Is a lunar eclipse of Kepler 40c's moon likely to happen based on this evidence? Okay? So talk amongst yourselves. I'm going to give you about a couple of seconds.
No.
I don't think so.
You don't think so? So is a lunar eclipse on Kepler 47's moon possible based on this evidence? Possible. No? Okay. Is a lunar eclipse on Kepler 47's moon likely to happen, Chloe, based on this card right here?
Oh.
Yeah, this right here is the moon. So it's showing you, this is the moon, this is Kepler. No, these are the 2 stars, this is the circle right here, and the around here is the orbit. Okay, so here's the moon, this little dot right here. This is Kepler 47. Kepler 47 is the name of a planet. The planet is orbiting star A and star B both in one solar system. Okay? In our solar system, we only have 2. So Kepler 47 has one moon, and it's asking you if you think a lunar eclipse would be possible for this moon with 2 stars and its
This
planet.
would all it had to do is go to the line
That's what it's asking.
eliminating the sun off the earth. But
Okay.
if it lined up with that, there's still light coming from the star. If it lined up with the star.
Okay. Alright. Thumbs up if you think that a lunar eclipse is possible. Thumbs down if you do not think it's possible. Ruby says thumbs down. Chloe, thumbs down. Okay, thumbs down, thumbs down. Alright, okay. Okay, do you think a lunar eclipse is likely to happen? Thumbs up or thumbs down?
Wait,
If you do not think it's likely to happen, thumbs down. If you think that it is likely to happen, thumbs up.
with the Kepler 47?
Uh-huh. Okay. Alright. So next you're gonna be on page 97 in your packet. Page 97 is a drawing, okay? So, I need all eyes on me. All eyes up here. Make sure. Ruby, looking for you. Okay, I can't see you. Thank you. Okay, we've got the sun in the middle. This is our solar system. We've got these little circles right here that are labeled 1 through 8. That is the Earth. This pattern, this dotted line around the 1 through 8 circles represent the moon's orbit. So, what I would like for you to do is to take time to figure out if and where a lunar eclipse can happen in our solar system. Y'all should know this. We've done it a couple of lessons so far, okay? Now, I want you to remember, the sun shines and its light does not curve. It goes in straight lines, okay? Straight lines, complete lines. And remember, when light hits a sphere, what happens? Does it go around? Does it curve? Does it stop? Okay, so I'm going to give you a couple of minutes to go ahead and fill this out. You are going to draw it, okay? So if I wanted to draw a lunar eclipse, if I wanted to draw a lunar eclipse, where would I need to put this dot, Cariana? Where would I need to make a representation of my moon? If I wanted to represent a lunar eclipse, where would I need to put the moon? Like which number and where?
1.
1 where? Right here?
Yeah.
Right here?
On the other side.
On the other side? Like where exactly?
Behind.
Okay, so right here?
Yeah.
Right here?
No, not over. A little bit more down. Yeah. Like right in between those two.
Okay, right in between. Okay. Okay. So right here. Okay, so if I draw this right here, meaning the ray that's coming off, it would not hit.
Natalie Neal, come to the office.
moon,
Natalie
right?
Neal to the office.
Okay, so remember that the line only goes in a straight line from the Earth. Y'all are correct. Okay, so I want you to label as many positions that you can on that page. Okay? Go ahead, you can work with your partner and discuss with your partner. That's good. No, that's right. You want to just draw it, so draw the dots, and then you'll go down at the bottom and select which position you felt like had a lunar eclipse around here. No, you can, no, it should be me. Yeah, so whichever position, so we have position 1, you have, yeah, so whichever positions you think can have a lunar eclipse.
Rotation too. Do we have to rotate the moon as it goes to different phases?
No, you're just trying to lunar eclipse.
Oh, no.
A lunar eclipse could happen when the Earth is in position 1. Yes, we just did position 5. Can it happen? Okay. What about number 2? It could. Tell me. But can a lunar eclipse work if you think about the moon phases? If this is a full moon, right? It's illuminating on all of that. Okay, no, excuse me, this is the Earth. So if this would be a full moon or a lunar eclipse, what would be the next one? Like, you need to make sure, because right here, it could round over here if you put it over here. I see how you're thinking. I see how you're thinking. Coming to you, just give me 1 second.
I know.
No, you don't have to. It's just for you to help to understand like where the sunlight is going, right? Okay. So next you're gonna complete part 2, which is the next page. Page 98. This time you are going to indicate where a lunar eclipse could possibly happen with star A and star B in the middle. Okay? So the numbered ones right here, 1 through 8, is Kepler 47c. You're going to figure out where Kepler 47c's moon needs to be to have a lunar eclipse. Now remember about where the sunlight is hitting, okay? So if we go right here, you've got overlapping suns. You have 2 suns, not just one. So some of the rays that are coming from the sun may hit different spots that you didn't think about. So be sure to remember that it's going to go in straight lines, okay? Now go ahead and start page 98. You're going to draw a moon just like what you did last time. But it would be beneficial if you went and did the rays that's coming on, right? Okay, so they're going in straight lines around. So where could it definitely block? 1 and 5. Okay. Now I want you to use what you know about the rays coming off of the 2 stars. Obviously they're going to overlap. Okay. And figure out, is it the same as our solar system? Is it different? How do you know that it's different? Right. Okay. So it's basically the exact same thing, but you have to take into account that you have these different rays that are coming out here, okay? Look. Imagine my lines as light rays that are coming in straight, exact lines, okay? So where is a definite yes, there will be a lunar eclipse? Where? No. A definite, for sure, there will be a lunar eclipse. Yep, why right in there? No, not right. What's blocking it?
On 5.
Yes.
Star B.
Yes. What'd you pick? You just got 2?
5 and 1. Opposite side.
Yeah. Okay. You got it, babe? What'd y'all figure out? Only 2 places, you think?
I guess too.
You
The
guessed
only
2?
spot where it lines up perfectly.
Okay. Alright, so, great. So now I want you to go ahead and sort your claims and your evidence. So you have your question, I'm going to borrow this. You have your question. Put it at the top of your desk. You have B, go ahead and take out B and C that we put aside earlier. And sort them based off of your 2 cards, claim 1 saying yes, claim 2 saying no, okay? You have evidence.
No.
I want you to work with your group to figure out which evidence goes under which claim. When you get done, raise your hand and I will come check it. I get it. So go ahead and turn it right here. All of y'all work together to figure out which one does. Yes, a lunar eclipse will probably happen. No, it will probably not happen. So we've already looked at this. What did y'all say with this? No. Y'all said no with this. Alright, let's look at this one right here. This is about the moon orbits per year. We have the moon that orbits the earth 12 orbits per year, and about 2 lunar eclipses per year on our moon. Okay? Deimos, which is orbits Mars, orbits 550 orbits per year, and there's more than 100. So do you think that evidence tells you that different moons can have different, okay. Probably will, okay. What about this one? Look at this one right there. Y'all got it? Okay. Well, it is data, so you have to just kind of go with what it gives you. But that's good. Y'all can go ahead and close your book, close these right here since y'all are done, and go behind the door and grab a exit ticket and go ahead and start filling that out. Y'all clip them back together. We're gonna use these tomorrow, so go ahead and clip them back together. Yes, ma'am. Great, that's good. Go ahead and clip them out together. We're gonna use these tomorrow, so you can go ahead and clip them back together and go and get an exit ticket over there. Okay, that's okay. Y'all go get an exit ticket. Go ahead and close these in. Turn, hey, y'all please turn those into, these packets right here, into the number 6 drawer, okay? Be sure to put your paper clip items together and paper clip them together, okay? Exit ticket. Hey, one at a time, please. Just rip it off. That's okay. Yep. Go back, have a seat and fill it out. Thank you. Rip it off, one at a time, please. Thank you, thank you. No, oh yeah, well, it's okay. You can just be sure to put your name on the back, okay? Put your name on the back. Charlie, can you give me one? You get one. Go ahead. You need to be done with it. Got a couple of minutes left to the bell, so here, I'll get you one, babe. Go. Be sure to put your name on the back, directions, turn into the drawer whenever you are on your way out. Based on the evidence, do you think it is likely for Kepler 47c to have an eclipse, lunar eclipse on its moon? Why or why not? Why or why not? Are you done? Okay, be sure to go follow the directions right there. And go in the back, turn it into the drawer, please. I lost your paper clip. Okay. No, in the drawer. Okay, so what piece of evidence made you think that yes, there will likely be a lunar eclipse on its moon? C. What did C say?
Something, oh, there's like, C was, something like those tilted, I think.
The orbits were tilted. Okay, that makes sense. Okay, what about you, Ruby? Different moons did different things, but they more than likely were going to have a lunar eclipse. What about you, Chastity? You didn't think it was going to happen at all. Okay, what was your, have a seat please. What was your evidence to back that claim up, that you didn't think it was going to happen? Part A, okay? So the model was the one, okay? Was there anything that you found interesting about today? What?
That there was 2 suns.
That there is 2 suns.
That was kinda cool.
That is kind of
Weird,
cool.
but cool.
So how do you think that you would feel on a planet with 2 suns? Way too much heat, okay?
There would be no rotation.
You don't think there'd be a winner?
We had it.
Probably not.
Very mild winter. Chloe, can you put that up? Just thank you. What did you find interesting about Kepler 47? Okay. What about you, Christian?
There's no solar eclipse, I mean, lunar eclipse mostly.
There's no lunar eclipse mostly. Okay.
The night's gonna be short.
Yes, you can. I will put in a pass for you. Okay.
Does that make sense? Okay.
Okay, so card A was the orbit of Kepler 47. Okay? It showed that it orbited around its moon, and it showed that it orbited around 2 suns, star A and star B. Card B was tilt of the orbit. So it was Rochelle who said about the tilt of the orbit that she thought, okay? I'll give you all these back.
Talk about it.
Bella Barnett, go to Miss Jade's room. Bella Barnett, go to Miss Jade's room.
Every time wrong.
Okay, so the orbit, pull that one up. This one right here, card B. Okay. So do you remember whenever I told you that not to think that every time the moon is the Earth's moon is behind the Earth, that it's going to be a lunar eclipse? Why is that?
The conditions have to be just right.
Okay.
Like, it
You're
just-
talking about on our Earth or
Yeah, no, on our Earth.
It just has to be just perfect.
Okay.
because the rotation is slanted, so it doesn't line up perfectly every time.
Rotation is slanted, so it doesn't line up perfectly every time. Okay, what were you going to say? That's what you're going to say? Okay, so what about the orbit on Kepler 47? What does it show?
Well, it's got, its rotation's pretty even, but, I mean, it's harder for there to be a lunar eclipse with the 2 suns, because it only, like, it has to, like, line up perfectly and, like, fully illuminate the sun off of the Earth or the moon,
Okay,
and it's hard when there's 2 suns,
it is.
because it's taking more space than one sun would.
Okay, so most of the moons in our solar system have orbits with almost no tilt. Most of the moons in our solar systems have orbits with no tilt. So what would you put that under? Claim 1 or claim 2? Claim 1 that says, yes, there will probably be a lunar eclipse. Or no, claim 2, there will probably not be a lunar eclipse. Claim 1. Okay. So let's use these to create a scientific reasoning chart, okay? So, what we're going to do is do our graph. Alright, what's our question? Raise your hand. Yes.
You talking about claim 1?
No, what's our question? Our question.
During a year, will there be a lunar eclipse of the moon of Kepler 47c?
Okay, what's our claim? Raise your hand for if you want claim 1, Kariana, or raise your hand if you want claim 2. Hi, we're doing a poll. 2, 1, 2, 1. Kariana, what do you pick? 2, 2. It's pretty even. Okay, so let's do yes. Probably will be 1. Okay. What was the number 1 evidence that you thought was yes, probably? Number 1 evidence.
Its rotation being even.
Rotation being even. Charlie, why does it matter that a rotation or an orbit, okay, we'll put orbit, being even around a planet, why does that matter that there will probably be a lunar eclipse? Why would that matter?
Because ours is tilted and like when it goes to different phases, it's like goes downwards and then comes back up, so it needs to be somewhere in the middle. If it was just like around and not tilted, it'll every new moon it'll be a lunar eclipse.
Okay, so more lunar eclipses. Okay, so that's our reasoning. That's what connects the, what? To what? It connects this to this. It connects the evidence to the claim. That's our reasoning. More lunar eclipse due to tilt. Alright, what's another claim that's going to help us say yes, probably? Kariana?
I don't know.
Can somebody help her? Caleb? Look in front of you. Which one do you think would follow? Yes, probably will be a lunar eclipse. Which one? Card C? What's card C say? Well, explain it to me. Anybody else want to help him? Christian? What do you think card C is saying right here? Mm-hmm. What gets 550 orbits per year? On Mars, yes. So there's over 100 lunar eclipses per year. So Mars has over 100 lunar eclipse per year. What's our reasoning? Why does it matter that Mars has over 100 per year? So yes, probably Kepler 47's moon will have a lunar eclipse. Chloe, why does it matter? Why does that matter that Mars has over 100?
The heat?
Huh?
I don't know, the heat.
Okay, the heat, okay. Charlie, Chastity, why does that matter? Why does it matter that Mars has over 100 lunar eclipses per year? So in different planets, different moons move, or was that other word? Different moons orbit. Okay, so in the end, we have found that 2 evidences that yes, probably there will be a lunar eclipse. Okay, so on your exit ticket, it wanted you to describe that. Can you describe to me what you put in your exit ticket? What'd you write on it?
I said if the evidence didn't match.
The evidence didn't match. Okay, so no. Okay? Alright, what about you, Chastity?
I put that, there could be, but it's not likely that the planets gonna line up.
Okay, good. Okay, we'll work on this tomorrow. Thank you so much. Thank you. Thank you, thank you.